Hello, welcome you guys to ACHIEVE'Rs Academy. So today we are going to look at the limit of a function. If you look at my previous video, we did something on limit of a function, but basically on general function of a limit. But today we are going to talk about special limits. Special limits. How can you solve questions based on special limits? Don't forget, you were told that special limits is different from general function of a limit. There are laws for special limit different, and there are laws for general limit different. So let's quickly run down to the laws of special limit we have. Number one law of special limit is limit of 1 over s as s approaches to infinity is equal to 0. Second, limit of cos s as s approaches to 0 is equal to 1. Thirdly, limit of sin s over s as s approaches to 0 equal to 1. Okay. Limit of cos s minus 1 over s as s approaches to 0 is equal to 0. The fifth one, you have limit of tan s over s as s approaches to 0 is equal to 1. Last one, you have the limit of 1 over s as s approaches to 0, as s approaches to 0 is equal to infinity. So, those are the special limits we have. If you look at these special limits, you are going to observe that our a is between 0 and infinity. It means a is arbitrarily large or small. So whenever you see your a as 0 or special or infinity, it means the question you are being given is a special limit, and how you are going to solve it. So let's solve example 1. Evaluate limit of 6s over s plus 1 as s approaches to infinity. Looking at this question, this is not a general function of a limit, because your a is what? A is what? A is 0 or infinity. So whenever you see this kind of approach as your a, it means the question is what? Is a special limit. And how are you going to solve it? So it's going to be different from the way you solve the general function of a limit using direct substitution method. Now, if I'm going to solve it using direct substitution method, it means whenever we are seeing s, we are going to put what? Infinity. So the question is now going to be limit of 6 infinity over infinity plus 1. So which is going to be 6 infinity over infinity plus 1. It doesn't make sense. So now, what are you going to do? Whenever you see a question on a special limit, the first thing you are going to do is you divide the highest power of s. You divide the highest power of s in both numerator and denominator. What did I mean by that? Solution. Limit of 6s over s plus 1 as s approaches to infinity. So divide what? Divide the highest power of s in both what? In both numerator and denominator. So now, and what is the highest power of s in this question? The highest power of s is known as what? S. which is s raised to power 1 is equal to s. So you can say that limit of 6s over s as s approaches to infinity over limit of s over s plus 1 over s. So limit of 6s over s cancel s. So you have 6 over s divided by s, 1 plus limit of 1 over s as s approaches to infinity. Now, you recall, in the special limit we given to you, we say that limit of 1 over s as s approaches to infinity is equal to 0. It means whenever you see limit of 1 over s, is going to represent, is going to indicate what? 0. So I'm going to recall that limit of 1 over s as s approaches to infinity is equal to 0. So that is now going to be equal to 6 over 1 plus 0. So that is going to be 6 over 1. So your answer is going to be 6. So whenever you are having a question like this, firstly you are going to check the approach, whether is a general method or is a special limit. And before a question can be in this general method, when it's having a real output value number. But when you look at A and S is approaches infinity, it means if S is arbitrarily large or small. So you are not going to use a direct substitution method. You make use of the word of a special limit. So that's why we have limit of 6s as s approaches to infinity to s plus 1. So you divide the whole of this equation by the highest power of s in both numerator and denominator. So, and once you divide it to be 6s over s, and then so into limit of s over s plus 1 over s. So your answer is going to be limit of, you must recall this statement. Mind you, you must recall this statement that limit of 1 over s as s approaches to infinity is equal to 0. So that indicates that whenever you see limit of 1 over s as s approaches to infinity, it's 0. So an answer is going to be 6. Now let's look at this example together. So we have evaluate limits of s squared minus 4s plus 3 over s squared minus 2 plus s cubed. Now, looking at this question, we can see as s approaches to infinity. So, looking at this question, we can say that this is a special limit, and you can't use direct substitution method, because in this case, if you are plugging your direct substitution method as s approaches to infinity, so you are going to arrive as infinity over infinity, and it doesn't make any sense. So the first thing you are going to do is what? You divided the highest power of s in both numerator and denominator. So what that means by that? It means limit as s approaches to infinity is going to be, the highest power of s is known as s cubed. Are you there? S raised to power 1. So the highest power of s here is known as s squared, which is known as s is going to be written as s squared over s squared minus 4s over s squared plus 3 over s squared all over limit as s approaches to infinity into s squared over s squared minus 2 over s squared plus s over s squared. Now, you have already taken the division method by dividing the both the numerator and the denominator by the highest power of s, which is s squared. Now, s squared divided by s squared is going to give us what? 1 minus 4 over s plus 3 over s squared all over 1 minus 2 over s squared plus 1 over s. Now, you recall that limit of 1 over s as s approaches to infinity is equal to 0. So that shows that this recall is telling us that whenever you see limit of 1 over s, example like 4 over s, 3 over s squared, 2 over s squared, 1 over s, they are still under this law of a limit, which is 1 over s can also be represented as what? 0. So the answer is now going to be here 1 minus 4 over s by 0 plus 0 over 1 minus 0 plus 0. So the answer is going to be 1 over 1. So the limit for this question is going to be 1. You can see that. So the first thing you are going to look is whenever you are given a question in a special limit, the first thing you are going to look is you look at the approach, whether the approach is in infinity or 0 or in a real number. So if it's in a real number, you use direct substitution method, and if it's in an infinity or 0, that means it's a special limit. So let's stop the last example here with me, and we can call it a day. Evaluate limit of tan s cube over s cube minus s squared. Evaluate tan s cube over s cube minus s squared as s approaches to 0. Now look at this question. This is also a special limit because the approaches is what? 0. And when you have approach as 0, it means it's a special limit. And don't forget about the limit. I said limit of tan s over s as s approaches to 0 is equal to what? 1. Now, I'm going to have something like this. The first thing you are going to do is you divided the highest power of s in both numerator and denominator. So that is now going to be limit of tan s cube over s cube multiplied by s cube as s approaches to 0 over. Now I can take the common factor among them. So what is the common between them? What common between them is s squared. So we are going to have s squared into, if I bring s squared out, I'm going to have s minus 1. So now we can say multiply by s squared. Sorry, this is going to be s cube s cube. So multiply by s cube. So I can easily say that this cancels this. So I'm having limit as s approaches to 0 is going to be tan s squared over s squared all over s minus 1. So as limit s approaches to 0. So now you have already taken the limit. Now you can recall that limit of tan s over s as s approaches to 0 is equal to what? 1. So I can easily say that whenever I see y, the whole of this space is going to be what? 1. So that is can easily say that 1 over, and s is known as what? 0. So you use your direct substitution method here into 0 minus 1. So your answer is now going to be 1 over minus 1. So the answer is going to be minus 1. So please, if you look at this question, you can see that we did only question of special limits, and those are the conditions that you are going to be given when you see your A is as 0 or infinity. So you know that that is a special limit. So we are going to stop here today. Thank you so much.